Introducing closures. Closures are self-contained blocks of code that can be passed around and used throughout the application code. We can think of an int type as a type that stores an integer and a string type as a type that stores a string. In that context, the closure can be thought of as a type that holds a block of code. What this means is that we can assign closures to a variable, pass them as arguments to functions, and also return functions from them. Closures have the ability to capture and store references to any variable or constant from the context in which they were defined. This is known as closing over the variables or constants, and the best thing is, for the most part, Swift will handle the memory management for us. The only exception is when we create a strong reference cycle, and we will look at how to resolve this in the strong reference cycles with closures section of this chapter. Closures in Swift are similar to blocks in Objective-C. However, closures in Swift are a lot easier to use and understand. Let's look at the syntax used to define the closure in Swift. As we can see, the syntax used to create the closure looks very similar to the syntax we use to create functions in Swift, and actually in Swift the global and nested functions are closures. The biggest difference in the format between closures and functions is the in keyword. The in keyword is used in place of curly brackets to separate the definition of the closures, parameter and return types from the body of the closure. There are many uses for closures, and we will go over a number of them later in this chapter. But first we need to understand the basics of closures. Let's start by looking at some very basic uses for closures so that we can get a better understanding of what they are, how to define them, and how to use them. Simple closures. We will begin by creating a very simple closure that does not accept any arguments and does not return any value. All it does is print hello world into the console. Let's take a look at the following code. Let clause 1 is curly braces function returns void in println hello world and curly braces. In this example, we create a closure and assign it to the constant clause 1. Since there are no parameters defined between the parentheses, this closure will not accept any parameters. Since the return type is defined as void, this closure will also not return any value. The body of the closure contains one line that simply prints hello world to the console. There are many ways to use closures. In this example, all we want to do is call it. We can execute this closure like this clause 1 function. When we execute the closure, we will see hello world printed to console. At this point, closures may not seem that useful, but as we get further along in this chapter, we will see how useful and powerful the closures can be. Let's look at another simple closure example. This closure will accept one string parameter named, but will still not return a value within the body of the closure. We will print out a greeting into the name passed into the closure through the name parameter. Here's the code for this second closure. Let's close 2, etc. This is the code. The big difference between clause 2 defined in this example and the previous clause 1, the closure is that we define a single string parameter between the parentheses in this closure. As we can see, we define parameters for closures just like we define parameters for functions. We can execute this closure the same way that we execute clause 1. The following code shows how to execute the clause 2 closure. This example, when executed, will print the message hello jump to the console. Let's look at another way we can use the clause 2 closure. Our original definition of closure states closures are self-contained blocks of code that can be passed around and used throughout the application code. What this tells us is that we can pass our closure from the context that they were created in, other parts of our code. Let's look at how to pass our clause 2 closure into a function. We will define the function that accepts our clause 2 closure like this. We define the function just like we would any other function. However, in our parameter list, we define a parameter named handler, and the type defined for the handler parameter is a string, returns nothing, void. If we look closely, we can see that the string returns void, the definition of the handler parameter matches the parameter and the return types that we defined for close to closure. This means that we can pass the close to closure into the function. Let's look at how to do this. Test closure close to. We call the test closure function, just like any other function, and the closure that is being passed in looks like any other variable. Since the close to closure executes in the test closure function, we will see the message hello dash printed to the console when this code is executed. As we will see later, as we will see a little later in this chapter, the ability to pass closures to functions is what makes closures so exciting and powerful. As the final piece of the closure puzzle, let's look at how to return value from a closure. The following example shows how to return a value from a closure. The definition of the close tree to closure looks very similar to how we defined close to closure. The difference is that we changed the void return type to a string type. Then in the body of the closure, instead of printing the message to the console, we used the return statement to return the message. We can now execute the close tree closure just like the previous two closures, or pass the closure to a function like we did with the close to closure. The following example shows how to execute the close tree closure. After this line of code is executed, the message variable will contain the hello body string. The previous three examples of closures demonstrate the format and how to define a typical closure. For those who are familiar with Objective-C, we can see that the format of closures in Swift is a lot cleaner and easy to use. The syntax for creating closures that we have shown so far in this chapter is pretty short. However, we can shorten it even more. In this next section, we will look at how to do this. Shorthand syntax for closures. In this section, we will look at a couple of ways to shorten the definition of closures. To use the shorthand syntax for closures is really a matter of personal preference. There are a lot of developers that like to make their code as small and compact as possible, and they take great pride in doing so. However, at times this can make code hard to read and understand by other developers. The first shorthand syntax for closures that we are going to look at is one of the most popular, and is the syntax we saw when we were using algorithms with arrays in chapter 3, using collections and Cocoa data types. This format is mainly used when we want to send a really small, usually one line, closure to a function like we did with algorithms for an array. Before we look at this shorthand syntax, we need to write a function that will accept the closure as a parameter. This function accepts two parameters. The first parameter is an integer named num, and the second parameter is a closure named handler that does not have any parameters and does not return any value. Within the function, we create a for loop, then that will use the num integer to define how many times it loops within the for loop. We call the handler closure that was passed into the function. We can create a closure and pass it to the test function this way. This code is very easy to read and understand, however it does take 5 lines of code. Now let's look at how to shorten this code by writing the closure in line within the function call. In this example, we created the closure in line within the function call using the same syntax that we used with algorithms for arrays. The closure is placed in between two curly brackets, which means the code to create our closures is the print line hello world from shorthand closure. When this code is executed, it will print out the message hello from shorthand closure 5 times on the screen. 5 times on the screen. In chapter 3, using collections and Cocoa data types, we saw that we were able to pass parameters to the array algorithms using the $0, the $1, $2, and so on parameters. Let's look at how to use parameters with the shorthand syntax. We will begin by creating this new function To accept the closure with a single parameter, we will name this function test function 2. The following example shows what to do with test function 2 the function. In test function 2, we define a closure like this, name it, thus colon string, returns void. This definition means that the closure accepts one parameter and does not return any value. Now, let's see how to use the same shorthand syntax to call this function. The difference between this closure definition and the previous one is $0. The $0 parameter is shorthand for the first parameter passed into the function. If we execute this code, it will print out the message hello from me 5 times. Using the $sign followed by a number with inline closures allows us to define the closure without having to put the parameter list in the definition. The number after the $sign defines the position of the parameter in the parameter list. Let's examine this format a bit more because we are not limited to only using the $sign and number shorthand format with inline closures. This shorthand syntax can also be used to shorten the closure definition by allowing us to leave the parameter names of the following example demonstrates this. In this example, our closure has 2 string parameters defined. However, we do not give them names. The parameters are defined like this: string. We can then access the parameters within the body of the closure using $0, $1. Also, note that closure definition is after the colon, using the same syntax that we used to define the variable type, rather than inside the curly brackets. When we use anonymous arguments, this is how we would define the closure. It will not be valid to define the closure like this. In this example, we will receive the error. Anonymous closure arguments cannot be used inside the closure that has explicit arguments. We will use the clause 5 closure like this. Clause 5 hello Kara. Since hello is the first string in the parameter list, it is accessed with $0. And as Kara is the second string in the parameter list, it is accessed with $1. When we execute this code, we will see the message hello Kara printed to the console. This next example is used when the closure doesn't return any value. Rather than defining the return type as void, we can use parentheses like the following example shows. In this example, we define the closure like this: function returns function. This tells Swift that the closure does not accept any parameters and also does not return a value. We will execute this closure as follows: clause 6 function. We have one more shorthand closure example to demonstrate before we begin showing some useful examples of closures. In this last example, we will demonstrate how we can return a value from the closure without the need to include the word return. If the entire closure body consists of only a single statement, then we can omit the return keyword and the results of the statement will be returned. Let's take a look at an example of this. In this example, the closure accepts 2 parameters of the int type and will return an int type. The only statement within the body has 2 parameters together, but if you notice, we do not include the return keyword before the additional statement. Swift will see that this is a single statement closure and will automatically return the results, just as if we put the return keyword before the addition statement. We do need to make sure that the result type of our statement matches the return type of our closure, the closure. All of our examples that were shown in the previous 2 sections were designed to show how to define and use closures on their own. These examples did not really show off the power of closures, and they did not show how incredibly useful closures can be. The remainder of this chapter is written to demonstrate the power and usefulness of closures in Swift. Using closures with Swift's array algorithms. In Chapter 3, using collections and COCO data types, we looked at several built-in algorithms that we could use with Swift arrays. In that chapter, we briefly showed how to add simple rules to each of these algorithms with very basic closures. Now that we have a better understanding of closures, let's see how we can expand on these algorithms using more advanced closures. In this section, we will primarily be using the map algorithm for consistency purposes. However, we can use the basic IDs demonstrated with any of the algorithms. We will start by defining an array to use: var guests John, Kim, Kelly, Carol. This array contains a list of names and the array is named guests. This array will be used for all examples in this section except for the very last ones. Now that we have our guests array, let's add a closure that will print a greeting to each of the names in the guest array. Since the map algorithm applies to the closure to each item of the array, this example will print out the greeting for each name within the guest array. After the first section in this chapter, we should have a very pretty good understanding of how this closure works using the shorthand syntax that we showed in the last section. We could reduce the preceding example down to the following single line of code. This is one of the few times, in my opinion, that where the shorthand syntax may be easy to read than the standard syntax. Now, let's say that rather than printing the greeting to the console, we want to return a new array that contains the greetings. For this, we will return a string type from our closure, as shown in the following example. When this code is executed, the master array will contain a greeting to each of the names in the guest array, while the guest array will remain unchanged. The preceding examples in this section showed how to add a closure to the map algorithm in line. This is good if we only had one closure that we wanted to use with the map algorithm. But what if we had more? But what if we had more than one closure that we wanted to use? If we wanted to use the closure multiple times or reuse them with different arrays. For this, we could assign the closure to a constant or variable and then pass in the closure using its constant or variable name. As needed, let's see how to do this. We will begin by defining two closures. One of the closures will print the greeting for each name in the guest array, and the other closure will print the goodbye message for each name in the guest array. Now that we have two of our closures, we can use them with the map algorithms as needed. The following code shows how to use these closures interchangeably with the guest array as follows. Whenever we use the greet guest closure with the guest array, the greetings message is printed to the console. And whenever we use the say goodbye closure with the guest array, the goodbye message is printed to the console. If we had another array named guest2, we could use the same closures for that array, as shown in the following example. All of the examples in this section so far have either printed a message to the console or returned a new array from the closure. We are not limited to such basic functionality in our closures. For example, we can filter the array within our closure, as shown in the following example. In this example, we print out the different messages depending on whether the name starts with the letter K or not. As we mentioned earlier in the chapter, closures have the ability to capture and store references to any variable or constant from the context in which they were defined. Let's look at an example of this. Let's say that we have a function that contains the highest temperature for the last 7 days at a given location, and this function accepts the closure as a parameter. Come on, I have coffee here around here, man. I haven't been drinking my coffee in 60 years. Bismillah. Now that's coffee drinking. We're gonna quit this Swift thing. Leave it to tomorrow. What we're going to do now? Now we're going to start with, we had JavaScript.